Alright guys, so our man's Antonio has not been feeling too good lately, so we thought we'd make him a graph of his feelings and do some calculus about it to cheer him up. So as you can see here, he was in depresso mode, then he got some hope, he got some more hope, but then there was some poor delivery in here. But since then, things have been looking up. So about the calculus, the graph here of his feelings of the continuous function g, the derivative of the function f is shown above. The function g is piecewise linear for -5 is less than or equal to x less than 3, and g of x equals 2 times the quantity of x minus 4 squared, for 3 is less than or equal to x, which is less than or equal to 6. Okay, so part A is asking if f of 1 equals 3, what is the value of f of -5? So we know that this is the derivative of f of x, and the integral of the derivative gives us the original function. So we're going to use integral of f of -5 equals f of 1, because that's where we're starting, minus the integral from -5 to 1 of g of x. And we know that since this is piecewise, we have to split this up into different parts. So we know from the problem that f of 1 equals 3 minus, so the integral is the area under the curve. We know the area here is positive and it's positive 1. We can do that by just counting on the graph. The area here is 0 because it's on the x-axis, and the area down here will be negative. So this part right here is -3/2, and this part is -9. So we have minus the quantity of -9 minus 3/2 plus 1, and then we do the math, and that comes out to 25/2. But you could also leave your answer here unsimplified, and that would also count as a point for the correct answer. Okay, so for points for this problem, there's 2 points. You get 1 point for using the integral here, and you get 1 point for correct answer, either simplified or unsimplified, doesn't matter. So for sample work, the student did it correctly. Here at f prime of x equals g of x, which is given. Then he used the integral to find what f of x is, which is the first point that he earned. Then you can see him calculating the area under the curve, and then he gets the correct answer at the end, 11 plus 3/2, which is the second point. So we got both points for this problem. Okay, so this student did not do it correctly. They were trying to use integral, which is correct, but they tried to integrate the equation of the second half of the piecewise function, which doesn't work. So they got an answer, but it was not correct because they used the integral of the wrong equation.
So for part B, it's asking us to evaluate the integral of 1 to 6 of gx dx. So we know that the integral just means the area under the graph. So from 1 to 6, it's 2-part, or like the piecewise. So we have to split it off into 2 parts and add them together. So the first part would be from 1 to 3. So we'll find the integral of 1 to 3 of gx dx, and we have to add it to the second part. Should be the integral of 3 to 6 gx dx. So to solve for this first part, we can just look at from the graph. We can tell that if we draw lines like this, that there'd be 2 squares. So there would be 4 squares. So the area for this part would just be 4. And we're given, from 3 to 6, we're given the equation that gx is 2 times x minus 4 squared dx. So to solve for this part, it would just be 2 brackets around 6 to 3, and to simplify this part, just be so normally you can just leave the answer like this, but if you were to simplify it out, the answer would be 10. So the 10 just means the area under this plus the area under this, which should equal 10. So for the AP scoring guide, this problem will be split up into 3 points. So the first point, to get the first point, you would need to split up the equation into 2 different integrals. So having these 2 parts will give you 1 point on the scoring guide. And for the second point, you have to write out the antiderivative. So having this part here will give you another point. And to earn the last point, you have to go through all the steps and then get the correct answer, which is 10. So this will give you another point, which results into 3 points for this part of the problem.
So for the student sample work, in part B, the response earned the first point with the sum of the 2 integrals in line 1 on the left. The second point was earned with the antiderivative expression in line 3. The second point would have been earned by numerical expression in line 4 with the no simplification. But with the correct simplification to 10, it earned the third point, resulting in a perfect score for part B. Student sample, in part B, the integral expression 3 times 3 plus the integral of 3 to 6 gx dx in line 1 did not earn the first point because it equals 4, not 9. This response used substitution of variables to write the integral of 3 to 6 2 times x minus 4 squared dx in an equivalent form. The antiderivative in line 4 is incorrect, and the response did not earn the second point. As a result of this error, the response is not eligible for the answer point.
So for part C, the question is, for -5 is less than x is less than 6, on what open intervals, if any, is the graph of f both increasing and concave up? Give a reason for your answer. So first, before you start the problem, you have to state that this g of x function is equal to f prime of x, because that states like the relationship, and it is the understanding that this g of x is like related to this f function. So we're going to write down here, so g of x is equal to f prime of x. And then, now that you've stated that, we can go on and look at this. So we know that you have to have your values be positive in order for it to be increasing. So you're only going to look at this first half here. And then, in order for it to be concave up, it has to be increasing, which would be these intervals from 0 to 1, and the interval from 4 to 6. And then after doing this, you're going to want to write a full sentence explaining like your reasoning for the question. Okay, so we wrote a sentence. For -5 is less than x is less than 6. F is both increasing and concave up on the open intervals of 0, 1, and 4, 6, because g of x is equal to f prime of x, the derivative of f. So that creates the relationship between this g of x line and f of x. And then we also say that the values are positive, which means that f is increasing, and g of x is increasing, which means that f is concave up. So for this question, you would first receive a point for having the correct intervals, and then you also would receive a point for having a valid explanation, for a total of 2 points. So this student wrote, on the interval 0, 1 and 4, 6, f is both increasing and concave up, since f prime of x equals g of x, and g is positive on that interval, meaning f is increasing on that interval, and g is increasing on that interval, meaning f double prime of x is greater than 0 on that interval. Therefore, f is concave up on that interval. So they got 1 point for correctly identifying the intervals 0, 1 and 4, 6. Then they got their other point by correctly having a reasonable explanation. So they identified f prime of x is equal to g of x, and they also stated that g is positive, which makes f increasing, and that g is increasing, which means that f is concave up. This student wrote, from 0 is less than x is less than 1, and 4 is less than x is less than 6. The graph of f is both increasing and concave up because f prime is above the x-axis, positive, and has an increasing slope. They received the first point for correctly identifying the intervals. However, they did not receive the second point because they failed to identify the relationship between g of x and f prime of x. So for part D, it asks, find the x-coordinate for each point of inflection of the graph of f. Give a reason for your answer. So, first of all, just like we did in the previous problem, we have to state that g of x is equal to f prime of x, stating the relationship between the f function and this graph. After that, we have to find the point of inflection. So as we can see here, in this section, it goes from decreasing to increasing, which signals a change in concavity, from concave down to concave up. So that means that this 4 here must be this point of inflection. So you have x equals 4. Now we have to write a sentence for it. So we wrote a sentence. The graph of f has a point of inflection at x equals 4 because g of x is equal to f prime of x, the derivative of f. And at this point, the g of x function switches from decreasing to increasing, meaning that the f function is switching from concave down to concave up. So first of all, we get 1 point for having the correct point of inflection. And then our second point is given by proper justification. So we stated the relationship between the g of x function and f. And then we also stated that it is going from decreasing to increasing. So we get another point for our explanation, creating a total of 2 points. The student wrote that f has a point of inflection at x equals 4 since f prime of x equals g of x, and since g switches from decreasing to increasing at x equals 4. Therefore, f double prime of 4 equals 0 at that point, and would change signs from negative to positive at x equals 4. Therefore, x equals 4 is an inflection point. So they got 1 point for correctly identifying the point of inflection, and then they also got their second point from having a reasonable explanation stating that f prime of x is equal to g of x, and that the g graph switches from decreasing to increasing. The student wrote that there is a point of inflection at x equals 4 because the slope of f prime changes from decreasing to increasing. They received 1 point for correctly identifying the point of inflection. However, they did not receive the second point because they did not state the relationship between g of x and f prime of x.